All right, welcome to the deep dive. Today, we're taking a look at something you guys requested, ASML.
Yeah, the Dutch company you probably haven't heard of, but
But they make the machines that make the chips.
exactly.
And those are in basically every piece of modern technology.
Pretty much, yeah. All those little brains.
So, for this one, we're going deep with Marc Hijink's Focus the ASML Way.
Really fascinating book. Gives you this image right at the start, like a starry sky, but every point of light is actually a microchip.
Oh, wow.
Yeah, and I mean, think about it. Your laptop, your phone, your car, probably even your refrigerator these days.
And they just keep getting more and more powerful, too.
Right, Moore's Law. Yeah, the idea that the number of transistors on a chip doubles every couple of years.
So cheaper, more powerful all the time.
Exactly. And that trend is just, I mean, it's transformed the world. And the pandemic really brought that into focus.
Oh, yeah, definitely. Suddenly, everyone needed more processing power.
Everything went online overnight, work, education, you name it.
All those Zoom calls.
Right. And the demand for chips just exploded, showed how much we rely on them.
We really do. And ASML is at the heart of it all. Kind of crazy, right?
A little bit, yeah. It's a classic, like, underdog story.
They started as this small Dutch company, what, like 40 years ago?
Yeah, and now they're the undisputed leaders. Their headquarters in Veldhoven is constantly expanding.
And actually, there's a leadership transition happening right now.
Yeah, Peter Wennink and Martin van den Brink are stepping down.
So lots on there.
It's worth remembering the U.S. was, like, the original leader in chip technology.
Right, Silicon Valley and all that.
So ASML's rise is really something. Even President Biden was kind of caught off guard by how important they are.
Yeah, so in this deep dive, we're going to explore all of that. Their origins, the innovations, the partnerships that made them successful.
The competition, the geopolitical stuff, it's all pretty fascinating.
It really is. We'll look at their collaboration with Zeiss for optics, TSMC for manufacturing, the rivalry with Nikon, all that.
Yeah, and of course the U.S.-China tech war.
Big stuff. So let's rewind to the very beginning.
Okay, so ASML was born in the early 1980s. Collaboration between Philips and ASM International, both Dutch companies.
Right, both Dutch.
But their first machine, the PS2000, it wasn't exactly a hit.
What happened?
They used oil-based hydraulic motors to move the silicon wafer table.
Oil? That doesn't sound good.
Yeah, as a problem, the oil particles would contaminate the wafers.
Right, those things are super sensitive.
Extremely. Even microscopic impurities are a no-go in chip manufacturing.
So the machine was basically useless.
Pretty much, yeah. Couldn't sell it.
What a way to start.
But this setback actually led to a big innovation. Philips NatLab research facility came up with a solution.
So they didn't just give up.
No, they developed linear electric motors. These use magnetic fields to create movement.
So no more oil particles.
Exactly. That was a big advantage, especially for their clean room requirements.
Right, but I imagine this new technology wasn't cheap.
Yeah, it drove up costs. The Dutch Ministry of Economic Affairs, they'd been providing subsidies.
They must have been getting nervous.
Yeah, they threatened to pull funding unless Philips showed some serious progress. And that's where this entrepreneur comes in.
Oh, who is that?
Arthur Del Prado, quite a guy. Survivor of a Japanese prisoner of war camp, went on to distribute U.S. semiconductor technology in Europe.
Wow.
Yeah, and he built his own successful chip equipment company, ASM International.
So the ministry saw potential there.
Yeah, ASM had recently had a successful IPO on the NASDAQ, so the ministry suggested a collaboration.
Okay, so they kind of forced them to team up.
In a way, yeah. But Win Trist from Philips, the guy overseeing the lithography project, he had some doubts.
About what?
Del Prado's connections, or lack thereof. He didn't think Del Prado had the right, high-level contacts within the big chip manufacturers.
Right, because selling a lithography machine, that's not like selling, I don't know, a car.
No, it's a huge decision. You need board-level approval.
Yeah, that makes sense.
So ASML was officially formed, Troost retired, and Charles Smit took over as CEO.
This is starting to sound like a pretty complicated family tree.
Yeah, a bit, but Smit was another Philips veteran, background in astronomy and aerospace.
Interesting mix.
Apparently, his colleagues thought he was crazy for leaving a stable job for this venture.
It was a big risk, right?
Dude. And looking back, Smith himself admitted that ASML seemed doomed from the start.
Oh, wow.
Yeah, and his experience at the Semicon Trade Fair in Silicon Valley in 1984 really highlights that.
So what happened there?
He went there hoping to get some interest from the big players, Intel, Texas Instruments, all those guys. They basically ignored him.
Ouch.
Yeah, the established companies, PerkinElmer, Nikon, GCA, they didn't see the need for another competitor.
So what was the message they gave him?
Essentially, come back when you've told 50 machines.
That must have been discouraging, to say the least.
Yeah, very demoralizing. But somehow they persevered.
What do you think it was that kept them going?
Well, Smith himself was incredibly determined. He went back to ASM and Philips, and asked for a massive increase in investment,
How much are we talking?
200 million guilders. Way more than they initially planned.
So he was basically betting everything on ASML.
Yeah, he convinced the board that ASML wasn't just trying to participate, they wanted to lead. He used the aircraft industry as an analogy.
Interesting.
He envisioned ASML focusing on the overall design of the machines and outsourcing most of the component manufacturing.
Kind of like Boeing and Airbus.
Exactly. He also understood the importance of maintenance and close collaboration between, marketing and engineering.
To make sure customers were getting the most out of their machines.
Right, so that early vision, that ambition, it probably played a big role in their perseverance.
It's amazing how a clear vision can really fuel a team, even when things are rough.
Yeah, it gives you something to aim for.
And in 1985, they took another big step, starting construction on their headquarters in Veldhoven.
Yeah, they moved quickly, built those critical fuss-free clean rooms in less than a year.
So they were, like, all in at this point.
Oh, yeah. And they even had some issues with the local municipalities. Eindhoven and Son weren't too happy because the permits weren't fully secured.
But ASML just kept pushing forward.
They had to. They couldn't afford to wait. And their go-to-market strategy was pretty smart. Instead of trying to win over the giants right away, they targeted smaller chip companies.
The ones who might be more willing to take a chance on a new player.
Exactly. Those companies were looking for an edge, and ASML offered better value of ownership.
Meaning?
Better return on investment over the machine's lifespan. Performance, reliability, cost-effectiveness, all of that.
They figured the big guys like Intel and IBM would stick with what they knew.
Yeah, they were probably right about that.
And then, a big moment. Philips placed an order for the PAS 2500.
1986. Equipped with a standard lens from Zeiss.
So the company that basically spun them off was now one of their first customers.
Yeah, big vote of confidence. But this early success also caused some friction with ASM International.
Oh, why is that?
Del Prado was reportedly unhappy with the constant need for cash injections and Smith's spending habits. Like, there's this story about Smith telling Steve Whittacook to just take the Concorde for a business trip.
Sounds pretty extravagant.
Yeah, it was a different time. And that financial strain led to a leadership change. ASM pushed for Clive Segal to take over.
Another name for the family tree.
Right. But then Segal apparently didn't even show up for his first day. Didn't realize he'd actually accepted the job.
Oh, wow, that's awkward.
Yeah, so Wim Troost stepped back in as interim CEO.
So all this chaos, was it actually good for ASML in the long run?
It might have been. They weren't forced to just copy other companies. They had the freedom to develop their own culture, their own strategy.
That makes sense.
An American startup in the same position, they probably wouldn't have had that kind of leeway.
Yeah, the pressure to deliver immediate results would have been intense.
Exactly. And those partnerships with Philips and the Dutch government, those were crucial in the early years.
They kept the lights on.
Literally, yeah. Philips stuck with them through those tough times, even when the machines weren't selling.
It's a good example of how deep tech ventures sometimes need that long-term vision.
Definitely. And the Dutch government, they recognized the importance of a strong domestic chip industry.
They'd seen what happened with Japan.
Right, they didn't want to fall behind, so their investments were a lifeline for ASML.
Speaking of lifelines, their partnership with TSMC was huge, right?
Oh yeah, the Taiwanese semiconductor manufacturing company, they were described as surprisingly like-minded.
What do you mean by that?
They both operated with similar speed and, well, a certain amount of organized chaos.
And they were completely dependent on each other.
Right. ASML needed someone to buy their increasingly complex machines, and TSMC needed those machines to make the most advanced chips.
We have their backs and they have ours. That was their mantra.
Yeah, it was a great partnership, fueled the boom of the Taiwanese chip industry.
It's fascinating how those two companies working in different parts of the value chain really drove each other's success.
A classic win-win. And while that was happening, Philips gradually reduced their stake in TSMC.
Oh, interesting.
Yeah, they eventually sold all their shares. With hindsight, kind of bittersweet for the Netherlands.
I can imagine.
They earned billions, but they also gave up a piece of, a massive, massive pie.
Yeah, TSMC's value today is just astronomical.
Right. And in 2006, Philips completely exited the semiconductor market. They spun off their chip division, NXP.
So they're completely out of the game now.
As far as chip manufacturing goes, yeah.
And Intel, meanwhile, they missed the boat on partnering with TSMC back in the 80s.
Yeah, they could only watch as TSMC took off with ASML's technology. As President Biden later said, America had lost its edge.
So that's a lesson in long-term consequences.
Big time. Strategic decisions in this industry can have huge, lasting effects.
Now let's talk about another crucial alliance. ASML and Carl Zeiss.
The German masters of optics.
Their lenses were essential for ASML's machines.
Absolutely. And Zeiss itself has a fascinating history. Deeply strategic company, especially after World War II.
The Allies were very interested in their lens technology.
Oh yeah, that's a whole other story. But those early interactions between ASML and Zeiss, they were, well, let's just say they weren't always smooth sailing.
What was the issue?
There was a lot of skepticism, a lack of trust. Their operational styles were completely different.
In what way?
Zeiss was very meticulous, months-long cycles of hand measuring, polishing, remeasuring lenses.
Very precise.
Extremely. And that clashed with the fast-paced, volatile nature of the chip market.
Yeah, those guys are always pushing for the next big thing.
Right. And calm, something Zeiss took very seriously. It wasn't something the engineers in Brabant had a lot of patience for.
So a bit of a culture clash.
Definitely. And all this was happening while ASML was facing financial difficulties. It was the early 1990s.
What was the problem?
They weren't selling enough machines to cover the rising development costs, especially for the PAS 5500.
And Martin van den Brink was already pushing the limits.
Oh yeah, even back then he was going full speed ahead. But it put a strain on their finances.
He also had a reputation for being a little confrontational.
Yeah, he liked to keep people on their toes. But despite all the tension, the dependency between ASML and Zeiss just grew stronger.
They needed each other.
Exactly. Van den Brink, he was brilliant, but he also needed to trust people to really get things done.
And once he trusted you, you were in.
Yeah, but there were still these constant arguments about money, the lack of guarantees on those multi-million euro lenses.
If there were any errors, ASML had to foot the bill.
Right, and that caused a lot of friction.
So how did they survive this partnership?
It all came down to sharing the risks and the profits. After 2 years of really tough negotiations, they finally reached a new agreement in 2007.
What did that involve?
ASML agreed to pre-finance a big chunk of the lens value. That reduced Zeiss's risk.
So they finally found some common ground.
They had to. Van den Brink, he actually even floated the idea of just buying Zeiss outright.
Wow, just cut to the chase.
Yeah, that was his style. But for the Germans, that was never going to happen.
Their lenses were like their crown jewels.
Exactly. And Zeiss is owned by the Carl Zeiss Foundation. They're fiercely independent.
So no merger.
No. But the collaboration, it just kept getting deeper. It's a good lesson in, understanding your partners.
Their long-term goals, their values, all of that.
Right. It's not just about the technology.
Speaking of which, let's talk about Martin van den Brink himself.
A fascinating guy. Grew up in the Dutch Bible Belt, dyslexic, which back then there wasn't much support for learning differences.
Right.
But he went to engineering school, specialized in power electronics.
And he was obsessed with energy transfer?
Almost, yeah. Even considered working on district heating before he saw a brochure for the PAS 2000.
That's what sparked his interest in ASML.
It was. He was hooked.
So what was he like to work with?
Intense. Very focused. Steve Wittekoek, ASML's commercial boss at the time, he initially found Van den Brink a bit much.
Really?
Yeah, too focused on the technology, not enough on the social side of things. Wittekoek even thought Van den Brink should never present to customers again after one particularly blunt encounter.
Oh, man.
But over time, they developed a good working relationship. Wittekoek mentored him, showed him the importance of building relationships, enjoying life outside of work.
Sounds like a valuable mentor.
He was. They even went on ski trips together.
I can't picture Van den Brink on a ski trip.
Well, apparently he was fearless on the slopes. Just went straight down, no hesitation.
Kind of like his approach to engineering.
Exactly. And that risk-taking, that determination, it defined his career. He wasn't afraid to push people, to push boundaries.
Wittekoek said sometimes you have to be hard on people to get results.
Yeah, and Van den Brink definitely wasn't afraid to be hard. In the mid-90s, he actually considered leaving ASML.
What happened there?
Word got out, reached the CEO at the time, Willem Maris, through AMD.
So the competition was worried about losing him.
Very worried. Maris realized how valuable Van den Brink was, so he basically gave him whatever he wanted to stay.
That's how important he was.
Yeah. Shows you how crucial it is to recognize and keep top talent, especially in a field like this.
And one of the things Van den Brink wanted was for ASML to start building scanners.
Yeah, this step-and-scan technology, it's kind of like, imagine you have a small, precise stamp, and you move it across a surface to create a larger pattern.
Okay, I'm following.
Step-and-scan lithography works similarly with light. It lets you etch much finer details onto the chip.
So it's like an Olympic runner who's also a really good artist.
Yeah, that's a good analogy. They're sprinting and creating a precise drawing at the same time.
Amazing.
And this approach used deep ultraviolet light, or DUV. It's a shorter wavelength, which increases the sharpness of the lines on the chip.
But I bet Zeiss wasn't thrilled about this new technology.
Not at first, no. Van den Brink had to convince them to adapt their lens design for DUV.
And that caused some tension.
Oh yeah,
But finally, with DUV and the scanner technology, ASML could really compete with Canon and Nikon.
Right, and the American companies were already falling behind.
So they were in a good position.
They were. And to keep growing, they needed more capital. Phillips advisor Hank Bott suggested going public.
An IPO.
Yeah, it was the best way to get the funding they needed. So in 1995, ASML went public on both the NASDAQ and the Amsterdam AEX.
Big step.
Huge. And to keep key employees, they offered share packages.
Smart move.
Yeah, but it caused some controversy at first. The Works Council thought the benefits should be more widely distributed.
That's a tough balance, keeping shareholders happy and making sure employees feel valued.
It is. But the IPO in March 1995 was a success.
Time to celebrate.
You'd think so, right? But the real celebrations came a few years later when those stock options vested.
Oh, right, because that's when people actually made money.
Yeah, suddenly there were 40 new millionaires in Veldhoven.
So did everyone go crazy?
Not really. It wasn't in ASML's culture to show off wealth.
They were more focused on the work.
Always. Results over outward displays of success. That was their thing.
I like that. And during all this young accountant from Deloitte was helping them with the IPO preparations.
Peter Wennink?
The guy who would go on to lead ASML?
Yeah, he was already making an impression.
So how did he end up at ASML?
It's actually a funny story. He was playing golf with ASML's financial director, Gerard Verdonschot, who was thinking about what to do after the IPO.
Golf course deals.
Right. And Wennink just casually asked Verdonschot if he wanted him to take over.
Bold move.
Yeah, but Wennink was that kind of guy. He was being groomed for a top position at Deloitte, but ASML just had this pull.
It was exciting, right?
Absolutely. And Hank Bott, the chairman of ASML's supervisory board, he saw something in Wennink. He wasn't just a numbers guy.
He could connect with people.
Yeah, build relationships, communicate with customers. That was his strength.
They needed that.
Big time. So he started working alongside Van den Brink and the new CEO, Doug Dunn, a British guy.
So there's another new name for us.
Right, Doug Dunn. He was brought in with a specific mission to make ASML more efficient, more disciplined.
Now that they were a public company, the pressure was on.
Oh, yeah. Shareholders wanted results. So Dunn and Wennink, they started streamlining the organization.
But Dunn was known for being a bit of a tough guy.
Yeah, Iron Fist was the term used to describe his management style. He and his right-hand man, Stewart, they didn't sugarcoat things.
That probably ruffled some feathers.
It did. But Hank Bott, the chairman, he was happy with Dunn's focus on finances, as long as Van den Brink had the freedom to keep innovating.
So they had a good balance there.
Yeah, it worked. Dunn himself admitted he wasn't always easy to work with.
It's a tough job being CEO.
It is. And this focus on efficiency meant some tough negotiations with suppliers. Like Harry Van Pout of VHE, he saw his turnover drop dramatically because ASML suddenly reduced their orders.
That must have been difficult.
It was. And Zeiss wasn't happy either. Dunn's philosophy was all about being agile, not producing too much in advance.
Because the chip industry changes so quickly.
Exactly. You have to be able to adapt.
And then, a big move. ASML acquired Silicon Valley Group, SVG, in 2000.
Yeah, a $1.6 billion deal, paid in stock.
Wow.
Intel actually played a role in that. They were under pressure to keep SVG afloat because they relied on their machines.
So Intel encouraged the acquisition?
They did. They wanted to make sure American lithography technology stayed in Western hands.
And it secured Intel as an ASML customer.
Exactly. So business strategy and geopolitics all mixed together.
It always is in this industry.
Right. And this deal, it actually faced scrutiny from the Committee on Foreign Investment in the United States, CFI-US.
So the government got involved.
Oh yeah, ASML had to navigate all that Washington politics. Economic logic versus national security concerns.
Always a fun mix.
Right. The approval process took a long time, and Dunn actually resigned before it was finalized.
Oh, wow.
Yeah, he got his stuff back, including his leather coat and a cryptic greeting from the Pentagon.
That's a good story.
It is. But while the SVG acquisition did get Intel on board, the timing wasn't great.
Because of the dot-com crash?
Yeah, ASML's stock price and revenue tanked. They had to lay off a lot of people.
Tough times.
Very tough. And a lot of people within ASML questioned the whole SVG deal.
They thought it was a bad move.
They saw it as taking on a dying competitor with outdated technology.
But they were wrong, right?
In the long run, yeah. But at the time, it was a difficult decision.
Around the same time, the chip industry was facing another big question. What would be the next wavelength for lithography?
They needed to go smaller, below 100 nanometers. The existing technology couldn't handle it.
So they needed a breakthrough.
They did. And one of the key innovations during this time was immersion lithography.
What's that?
It involves using water. Basically, they create a mini swimming pool of water under the lens.
Water. Inside a chip-making machine.
Yeah, sounds crazy, right? But it works. They immerse only the area being exposed, and a ring of air keeps the water stable.
How did they even come up with that?
It's actually kind of funny. There was this accidental feature, a flattened lens in the optical system.
So a mistake.
Yeah, it was originally meant for alignment checks, but it was never removed. And it turned out to be perfect for ensuring the water layer had a consistent depth.
Wow, talk about a happy accident.
It really was. It shows you how unexpected discoveries can sometimes lead to big breakthroughs.
But while all this was happening, Nikon launched a patent attack against ASML.
Yeah, in 2001, they were watching their market share shrink, so they accused ASML of infringing on their patents.
Oh, man.
Doug Dunn realized they weren't prepared for this. ASML's patent portfolio was much smaller than Nikon's.
Nikon had been around for much longer.
Right, they had a huge history in optics. And in these patent wars, the side with more patents often wins.
So what did ASML do?
They fought back, they countersued Nikon, and assembled a team of experts to explain the technology to the International Trade Commission, the ITC.
They had to get the government involved.
They did, and Intel and Micron also helped behind the scenes.
They were worried about production disruptions if ASML lost.
Exactly. They needed ASML to succeed.
So how did it end?
In 2004, they reached a cross-licensing agreement, basically a ceasefire.
Everyone could use each other's technology without getting sued.
Exactly. It cost ASML $87 million and Zeiss another $58 million.
Expensive ceasefire.
It does, but it let them move on and focus on innovation.
Sometimes that's the best solution.
Yeah, sometimes you just got to cut your losses and move on.
Now, within ASML, innovation was like a religion, right?
Yeah, they had this system of fellows,
What were those?
individuals who are nominated based on their contributions, including patents.
So the best of the best.
The top inventors even had their faces engraved on silicon wafers.
Really?
Yeah, they displayed them like a Mount Rushmore of the chip industry.
That's pretty cool.
It was Van den Brink's idea. He was inspired by the physicists honored at Bell Labs.
I wonder if ASML will ever have a Nobel laureate in their ranks.
Who knows, maybe someday. But all this pressure, all this competition, it sometimes led to some pretty heated arguments.
Even between ASML and Zeiss?
Oh yeah, there's this funny story about a Zeiss technical director getting pulled over by the police.
What happened?
He ended up calling Van den Brink, who was known for his colorful language.
I bet that was an interesting conversation.
It was, but even though they clashed, they respected each other. They even laughed about it afterwards.
So it was all part of the process.
It was. But the money issue between ASML and Zeiss, that was a constant source of tension.
Especially those guarantees on the lenses.
Yeah, Zeiss was very reluctant to provide any assurances.
So how did they resolve that?
It took years of negotiations, led by Dupe Grote from ASML.
He must have been a patient man.
Very patient. But they finally reached a new agreement in 2007 that addressed the risk and profit sharing.
Finally.
Yeah, and Van den Brink, being Van den Brink, he even suggested just buying Zeiss.
He really wanted to solve that problem once and for all.
He did. But as we discussed earlier, Zeiss would never agree to that.
They were too independent.
Right.
Van den Brink also had this interesting philosophy about errors.
Yeah, his famous line was, "It's not about preventing errors, but how well you manage them."
Makes sense. You can't prevent everything.
Especially with machines as complex as ASML's.
Those things are so complicated, no one person can understand them completely.
Right, they break the design down into sections, different teams working in parallel.
It's like a giant puzzle.
Yeah, Hijink calls it an inscrutable machine of collaboration.
And this approach, it fostered a culture of continuous learning.
Exactly. You learn from your mistakes and you get better.
And for a chip factory, those machines are their lifeline.
If one goes down, the whole production line stops.
And they operate at incredible speeds.
Hundreds of wafers per hour, and each wafer could be worth like hundreds of thousands of dollars.
So any downtime is a big deal.
Mass.
And while the chip manufacturers keep their production formulas secret, ASML keeps a close eye on their machines out in the field.
Right? Because you never know what's going to happen.
Mechanical issues, sure, but sometimes it's even weirder stuff.
Yeah, like earthquakes, thunderstorms.
I read about that one case at Intel. Cow farts were missing with their yields.
No way.
Apparently, yeah.
It's amazing what can affect these sensitive processes.
It really is. And while all this was going on, the iPhone came along and changed everything.
Yeah, the mid-2000s, Apple revolutionized consumer electronics.
And ASML's technology, it played a role in that, even if it was behind the scenes.
Oh yeah, definitely. And while that revolution was happening, ASML was working on its own revolution.
EUV.
Extreme ultraviolet lithography. A massive undertaking.
And it wasn't easy.
No, not at all. Even getting the initial EUV license from the U.S. government was tricky.
Really?
Yeah, Van den Brink had to play some strategic games.
He used the SVG acquisition, which came with its own EUV license.
Exactly. It was a way to bypass some of the conditions.
So they were already thinking ahead.
Always. They were betting billions on EUV.
It was a huge risk.
Huge. Decades of development, tons of money poured into it.
And the first machines were pretty rough.
Yeah, they used a discharge lamp that took hours to expose a single wafer.
So not very efficient.
No, not at all. And they used a ton of power.
Van den Brink knew it wasn't a long-term solution.
Right. The real breakthrough came with the idea of firing lasers at molten tin droplets.
Molten tin.
Yeah, it sounds simple, but it was incredibly difficult to make.